Ameen Altajer. Over to you, Ameen.
Thank you so much, Ahmed. Hello, everyone. First things first, can you guys see my screen? Just to double check. Can you guys hear my voice? See the camera? Okay, I think we're good then. Perfect. Okay. Thank you so much for having me in here today. It's such a pleasure to be here. Super excited, honestly. And these are one of the times that, I get to change the tone of my speeches and I get to talk about one of the things that I really adore, which is game development and how AI can really integrate super well with that kind of thing. So first things first, this talk is going to be named How AI is Shaping the Game Industry, which is a bit of change of what you've seen so far in this conference. And yeah, let's get through. Okay, so a bit about me. My name is Ameen Altajer. So there's a lot to cover. I don't know where to start, but however, I can tell you one of my recent achievements, which is I've been labeled as one of Google developer experts, one of only 150 in the world in machine learning, which is a huge thing that I'm really proud of. However, if you're really interested, you can check out my work at ameenaltajer.com, and you can check out our work at INFINITEWARE.com, where we have a lot of products and services spanning the AI space. Okay, now I heard a lot of talk about chatbots and such, so I figured, that I want to also cover that we do have a chatbot that we've done probably in the last 4 to 5 years, which is an in-house product. It is called Kavria, which in a way does things completely differently from other stuff. We normally rely on machine learning a lot in order to understand the sentiment of the, of the requests that we get in our chatbot. And the beautiful thing is that it keeps learning on its own, which can really add a lot of value for an organization that has, let's say, specific jargons being thrown around all around the organization. And this is, by the way, an offline chatbot, which means it can really work for the government as well, if you don't want to have that sort of internet, let's say, dependency. Okay, enough about the background here. So what is AI to begin with, which is, again, the million-dollar question. And maybe if you guys want to hear about a much more game development specific definition. Well, if we really want to wrap everything like in a very concrete definition, I'll probably say that artificial intelligence ultimate goal is to bring some of the cognitive skills that we have as human beings, and give it and put it on the plate for machines, or let's say computers, honestly. And so this might seem so easy in the beginning, but honestly, when you really roam around and you understand the capacity of and the difficulty of such a job, you will understand why there's a lot of, let's say, hype going on so far on items like machine learning and subjects that are currently, roaming around in the internet. But the idea is so big that we humans fail to understand the scale of the issue. For a starter, so you can understand the scale of the issue here, we have so many things that we do and we take for granted. A good example is computer vision. So when we look at something, it's very easy for us to exactly detect what we're looking at, the things that we're looking at, understand the 3D shape of the things that we have in our sight. But to have the same cognitive skill and add it to a machine, that would take a very difficult, that's going to take a very huge feat to really, do such a thing. And so not only that, even pattern recognition and speech sensitization, for a very long time, those core skills have been only exclusive to the humankind. However, recently, there's a lot of advancements that happened, and now we begin to see a lot of things being covered also by machines, which is really, really great. But the ultimate goal is to have some of those cognitive skills that are conquered by human beings and let them in a way, make their way into our friends that are, computers basically and computer software programs. And so to understand the full map of artificial intelligence, and there's a lot of confusion here as far as I can probably tell, is that artificial intelligence on its own is a huge circle. So there's a lot to it. Yeah, so artificial intelligence is a huge circle. And as we said, it wants to cover, the cognitive skills being offloaded to the human, to the machine and computer programs in a way. But Inside that circle, we also have machine learning, and machine learning is a subset of artificial intelligence. So even though they're being used interchangeably, like back and forth, but to be quite honest, machine learning is only a subset of artificial intelligence. And the difference here is that machine learning, it tries to do whatever artificial intelligence is wants to do, but in a different fashion. So it learns automatically on its own. Now, if you talk about artificial intelligence, there's been a lot of let's say modalities within that circle. We have what we call evolutionary programming or evolutionary intelligence. We have other stuff as well. But within machine learning, what we're trying to do here is that we're trying to cover, the learning aspect. So we're giving the machine the exact feature to go and learn on its own from the data that it is exposed to without human intervention. And this is really, really huge. Now, deep learning, which is, again, another subset of the machine learning space, is a huge, huge advancement, I would say. And the beautiful thing about it is that you don't have to really be that, let's say, super involved with the data. You can just grab as much as possible in terms of data. Definitely, I'm making it much more, like it's much easier here said than done, of course. But all in all, you're relying on the inspiration that we got from biology, a thing that we call artificial neural networks to do that sort of thing. But basically, with deep learning, we have deep neural networks, very long, huge neural networks that tries to mimic how the human brain works in order to do that sort of intelligence. But that is the map all in all, in case you were wondering how things are being thrown interchangeably. Now, when we're talking about game development, things change the tone a bit. So when you're working on a game, the ultimate goal is to provide a gameplay experience that is really cool and interesting for the player. And that can mean that you have to do a lot of compromises along the way. You want to make sure that your AI agent, and I'll call the AI player here the AI agent, which is the exact jargon that we throw here in the industry. You want to create an artificial and a worthy contender. Again, somebody that is cool to play with, that might bring a let's say an effective challenge to the game, but at the same time, you don't want to make it seem like you have an AI agent that is completely super powered and there's no way to win, against that such a thing. And so this is the ultimate goal of game development. You have to do compromises in order to get to that goal. So you want to make the AI agent smart in a way, but at the same time, you want to make sure that they are capable of exerting, pressure as if they were, as if they were a human being. And so that is the ultimate goal. And when we're talking about fairness, it is very difficult to do that sort of, let's say, that sort of a change or let's say development within an AI agent in order to reach that sort of balance. It's easier said than done. And so having a fair contender is a very difficult thing to actually, reach. Now, what we were doing back in the day as game developers in order to get to that level is that we were having what we call heuristics, basically. And the idea is you want to have some of the rules that we human beings know and love, and we try to bring them in the game itself. So basically, if you ever done some programming, you will know that we have a construct that we call the if statement, if else. So where you put, if things are happening this way, then just do that. And this is exactly what we're doing if we're developing a game and we're adding an AI element to it. So we're trying to put multiple rules within the game, trying to predict how the player is going to behave. So if the player is doing that, you might want to do this. If the player is doing this, try to do that as well. And so this is basically what we call heuristics. And the idea is you have multiple rules that have been generated by human beings and then being baked within the game itself in order to have that sort of illusion that, hey, this game AI agent has a bit of intelligence, but at the same time, it's not being driven completely by the computer, and there's no way to win against those. So this was exactly how we used to do it back in the day. And there's a very common construct within that space, and we call it FSMs, which stands for finite state machines. Now, if you ask any AI programmer within the AI space, they will probably swear by this name, which is finite state machines. And the idea is very simple. So when you're building an AI for a game, you have multiple states. So imagine you have a chase state, in its act state, a die state, let's say, for example, or wonder state. So you have multiple different independent states. And the idea is you want to have you want to have the AI agent to switch between those states, among those states, depending on how the environment really acts. So imagine you have an AI agent that tries to guard a tower. The idea is pretty simple. So what you're trying to do here is that you want to, let's say, wander around trying to look for enemies. The second you look for an enemy, you switch your state from wandering or guarding to attacking. So you're trying to attack whoever that you have in your sight. So the idea is very simple. As we said, you have multiple states and you're trying to switch among those states, given the environment and how everything is laid out in the environment. So this is what we call finite state machines. It has been the, let's say, de facto standard in game development. A lot of work has been done there, and it's been, the #1 choice for game developers, let's say. Now, if we're talking about game AI, however, even though we talked about FSMs as the holy grail so far, as you can probably see them on the very left here, we also have other solutions and other choices if we're building game AI. So we also have things like behavior trees, decision trees. We have also pathfinding algorithms such as A*. And so this is what we call the deterministic kind, which basically means you're trying to build an AI system that has rules in it before you can really act. Now, this has been really, really great, but there's been a lot of research happening in the other areas, such as non-deterministic. And the idea is here, you want to have this sort of AI agent that does its magic without having the heuristics baked in within the game itself. And this is really cool because it means we can have less work done on the AI part without manually putting things. And in order to really appreciate how that is really, really important for us in the game development community, if you check out the people online, especially on YouTube, you're going to find that a lot of people trying to figure out specific quirks within the games that they play, and they manage to somehow win against those enemies by leveraging, let's say, a bug in the game so they can get to what they want. And this is really, really beautiful, but it tells you one thing, and that is game AI is not perfect. You can always figure out a specific twist, let's say, or a specific bug where you can go ahead and win in the game by leveraging a bug in the whole game or the AI part of it. And that is very obvious because the rules have been baked in within the game itself, as we said in the very beginning. So there's no dynamic, let's say, feel about it, which makes it very static. Now, the non-deterministic aspect tries to solve that by adding a dynamic feel to the AI. And what that means is, what you're trying to do here, you're trying to allow the AI agent itself, or the NPC, to figure out how to play the game on its own without giving it a lot of heads up material, without giving it a lot of, let's say, information in the very beginning to get on its own. And this is really, really beautiful. But this is basically the landscape of game AI. And there's a lot of modalities that we haven't explored here. So just to recap, so you can see what I'm trying to get to here. Now, in machine learning, or deep learning to be more exact, the idea is very, very simple. So the idea is you want to have data in whatever format that you guys have, be it images, be it Excel sheet, rows, whatever that you guys have. And the idea is you want to push all of that data into a generic algorithm, like let's say a neural network of some sort. And then you have to have a human element on board. So this is what we call a supervisor. And the idea that you're supervising the whole exercise. Basically, every time you have input being pushed into that algorithm, you want to supervise it and you want to make sure that, a good example, of course, is when we're trying to tell the difference between cats and dogs. As you're pushing an image of a cat for the machine to classify it correctly, you as a human being, you're saying that this is an image of a cat. And then as you did, and then when you have another, let's say, image for a dog, you say this image is also for a dog. And you go on and on and on and on and on until you get to that stage where the machine learning algorithm can be able to pick up that sort of difference on its own based on the data that you've fed in. And then it can exactly tell the difference. Now, this is how supervised learning really, really works. And from the name, you can probably tell it's supervised for a specific reason, because the human element has always been there from the get-go. And then the ultimate deliverable is what we call a model. So you can use that model to tell the difference between cats and dogs just by showing an image, because you spent a lot of time and a lot of effort trying to tell the difference between cats and dogs through the data that we acquired in the very beginning. Now, this is what we call supervised learning. In that case, even though it really works super well in a tremendous amount of industries like banking and insurance and other places, and even government, sadly doesn't work in the game industry. And the reason is, in the game industry, what we're doing is we're working in a dynamic environment, which means we have an environment and we have agents playing through. So we have a human agent, we have an AI agent, and they're playing in this dynamic environment, and everything can change and at an instant. And that doesn't really cover that supervised element in it. So we don't have data that we can just feed in from the get-go and have them all the work on its own. So there's a lot of stuff that we have to do as an AI agent in order to figure out how the world works. A good example is when you do a fair amount of exploration, a fair amount of exploitation. So those elements, they don't really work out in an environment that leverages supervised learning. And this is where our story takes us to the second element, which is the aspect of reinforcement learning, which is a really huge discipline. There's been a lot of focus on reinforcement learning lately. And the idea is, in reinforcement learning, you have an environment, which is the typical case that we have with games, and you have an agent. And then the ultimate goal is you want the agent to have the perfect action that can be done, okay, depending on how the environment changes. And the way we do that is that by specifying a specific thing that we call a reward. So imagine you have a very simple game like Tetris. What we can set up as a reward is the score at the top there. So what we can do is we can tell the AI agent, in order to win in this game, you have to maximize the amount of number that you can get. You want to have the biggest number that you can get in that digit that says score. So by specifying that function or that reward in that fashion, the AI agent is going to roam around in the environment. It's going to try to explore, it's going to try to exploit by trial and error, by the way, just like us human beings in the real world. And then it's going to get to that stage where it can exactly hone its skills and figure out that these sort of actions really work out in that environment. Those sort of actions are things that I don't want to explore with because I know that they have a lot of, let's say, damage if I do those. So by the mere idea of exploring and exploitation, the agent can pick up multiple techniques that it can, that it can exactly use in the real world. And this is what we call by reinforcement learning. So it's being reinforced by the experience that these agents go through in the environment. And so if I wanted to summarize reinforcement learning, I'll say the following. So reinforcement learning says that you'll be able to play by observing. And there's been a tremendous amount of examples that have been there in the past. So you've probably heard about companies like OpenAI or DeepMind, where they have a lot of work being done in this space. And they, for a great deal, really rely on reinforcement learning. And believe it or not, they actually start their experimentation with games. So whoever said that games are not useful, they might want to think again. And so, yeah, so the ultimate goal about reinforcement learning is learning how to play by observing. And remember, this is exactly what we do as human beings. We look at things and we try to make sense of how things work out, and then we participate in that sort of experiment or exercise. So that is it. A good example is the demo that you can see here. And that is really beautiful because if we have an environment that can learn on its own using reinforcement learning, we can also have not only a single game agent, we can also have a multi-agent environment. So you can, for example, have 2 versus 2 playing a soccer, as you can probably tell, and they can figure out the rules on their own just by observing how the examples work. So this is really beautiful because a complicated game like soccer that needs to be exactly coded in the game doesn't have to be that complicated anymore if you can just show multiple agents, multiple games, let's say, recaps of games, and then for them to figure out exactly how to go forward and pick up those rules that, hey, I have to take that ball and put it in the other destination, but at the same time, I can work collaboratively with my teammate in that game. So those sort of twists, those sort of quirks within the game itself can also be learned using reinforcement learning on its own in a dynamic environment, such as soccer, as you can probably tell, okay? A good example also is tennis. And remember, those rules are not baked in within the game. And this is what makes this sort of experiment really interesting and super, I would say, evolutionary, because you're just showing examples to the game agent, and then it has to pick up on its own those rules. So this is another demo as well. Yeah. So one of the things that really shocks, let's say, AI researchers in that space is that sometimes AI can even pick up nuances that human beings never really thought about. A good example is, and I really endorse, and I really urge you guys to pick up, to try to go to openai.com and see what OpenAI, which is a nonprofit organization, or used to be a nonprofit, now a for-profit company that does a lot of work in the AI space. You can probably see the type of experiments that they do with reinforcement learning, and you're going to be super amazed. So this is one of the things that I wanted to share with you guys. In the game here that they created is that you have the red team and they're supposed to touch the blue team members. And so this is the essence of the game all in all. And what we can see so far is that the blue team is trying to build that sort of fortress on their own to exactly, cover the place and make sure that they're covered and there's no, problem whatsoever with this. However, with reinforcement learning along the way, the red team has been doing some work on their own as well. And they managed to figure out that if they can pick up one of those tools, the boxes that are laid on the floor in the environment, they can exactly build a ladder and they can get on top of that sort of barrier and get to the blue team. So this was really, really amazing because initially when they built that sort of demo, the idea was to exactly get to the blue team in the fastest way possible. But along the way, the red team had to come up with new ideas in order to get to that goal. And remember, the reward here, if you want to, build that sort of analogy, just like what we've done in the beginning, the analogy in the older, like in the Tetris example that I made, is that you have to focus on the score itself and trying to maximize it. So when you build that in a reinforcement learning way in a game, you'll be able to tell the agent to work on its own in order to maximize that sort of goal. However, in this demo here, the ultimate goal and the ultimate reward is to allow that red agent to be as close as possible to the blue agent. And so for it to do that, it managed to pick up new ways and new items, by taking those boxes and stacking them on top of each other, in order to go over the barrier and jump over those guys in the blue team. And that was really, really amazing. And by the way, if you're really interested in knowing how things work on the inside, I really urge you to go to openai.com and exactly learn how all of those things are laid out in a technical, let's say, background if you're interested. So all in all, what I want you to understand is that even though we have been doing a lot of work in game development, especially in the AI space, we've been mostly working with things like finite state machines, behavior trees and such. And it is the time now that we consider much more serious endeavors such as reinforcement learning, where we're delegating more work to the AI agent to figure out the environment on their own, and not really have people to bake those rules as humans. Because as humans, we have a specific capacity. You can argue with me all day if you want, but we're biological beings at the very end. So we have a cap when it comes to our performance and our understanding of the world. And so when we're giving that choice to machines, and where they have an abundance of computational power and time, they can probably figure out tricks that we have never thought about in the very beginning. Okay, so I want you to understand that this is a very serious endeavor. And to put things here in context, so DeepMind, which is a company that got bought by Google for $500 million, so I forgot the exact amount, but DeepMind is now a subsidiary of Google, or Alphabet in this case, the company Alphabet. And they've been experimenting with reinforcement learning for a very long time. And one of their latest achievements was to have this demo that tries to play against what we call, a human player in this game that we call StarCraft, which is a very complicated game. There's a lot of elements to it in terms of strategy, tactics, and such. And so the idea with DeepMind is that they created a reinforcement learning agent that manages to learn on its own this complicated, really huge world. and then pick up the rules on its own and figure out the best strategy that can rely on in order to, win in the game against the human element, which was really, really interesting. So I really urge you to check out also DeepMind's work. So you have two different organizations that are really leading the research here. You probably heard about DeepMind, and you also have OpenAI. So go read about those if you're interested. Last but not least, if you are a game developer yourself, there's a specific package that is being distributed by Unity. And in case if you're wondering, if you're not coming from that space, Unity is a game engine which allows people to create games. So with Unity, you can now not only rely on the finite state machines, the, let's say, traditional ways of creating AI, you can also use reinforcement learning using machine learning and build a demo if you want on a real game for that matter, using ML agents, which is a superb experiment that has been done by Unity. So you don't have to be an AI researcher as such. You can just experiment with that package. And by the way, the code of that package is actually on GitHub, which is like the YouTube thing for software developers. So if you have access to GitHub, please check out ML agents, and you'll probably want to experiment with it as well. Before I go, and probably I'm not sure if I have questions. I'll check out the feed in a second, but I want to leave you with that thought. And this is a sentence that I always say to people. In the race of business, data can either make or break your business. And that is not only applicable, let's say, to businesses like insurance or banking or such, but that even can make a huge difference if you're talking about game development as well. So the more data you acquire about your players, the demography that they're coming from, how they act in each specific stage, you can also build the maximum, let's say the best experience that you can probably think about, in order to maximize that gameplay element that we talked about in the very beginning of this session. So yeah, just put that in mind. If you're interested, I have a lot of talks on Google that you can probably find on YouTube, spanning technical terms and even game oriented stuff. Thank you very much. I'm super glad to be here today, enjoying those sessions just like you guys. And I'm not sure if we have questions, Aman?
I guess there no questions so far.
Okay, perfect then. Okay, thank you.